Today we are looking at objective 23. We are going to find sums of infinite geometric series. So we're still working geometric. What does that mean if it's geometric? Multiplication. It's got a common ratio. Okay, it's going to be the same. It's got a common ratio. Okay, I'm figuring out the sum. How do I know I'm wanting the sum? What you get when you add all the terms together? Because it says what? And here, series. Series means sum. What you get when you take the first term and add it to the second term and add it to the third term and add it to the fourth term. And where are we going with this term? We're going all the way to infinity. So I'm going to ask you kindly, before I just pop in the formula and give you the definitions and you make zero connection to it at all, let's think about this. When I'm multiplying by something, let's say it's something bigger than 1. Let's say I'm multiplying by 2. That'll be easy enough, right? I'm going to times by 2. That's my common ratio. Times by 2, times by 2, times by 2, times by 2. What's going to happen to my sequence? It's going to get bigger and bigger and bigger and bigger and bigger and bigger. So let's just think about this for a second. Let's actually look at an example. Give me an easy starting point. 2, okay. And so we're going to times by 2, right? So what would my next number be? And then times by 2, then 64, 128, 256. And where is this going today? This is going to infinity. Where's infinity? I mean, I've got this set of numbers, and I'm adding all this. I want to know what 2 plus 4 plus 8 plus 16 plus 32 all the way to infinity. So I'm going to go to infinity, y'all. Goodbye. I'm going to infinity. My numbers are keep going, right? And I'm going to add, and I'm going to add, and I'm going to add. Yes, we're going to add. I'm going to infinity. Wait, I can't go to infinity. It never ends. So my question is, can I get a total sum? If it's getting bigger and bigger and bigger and bigger, and eventually it's getting so big it's spiraling out of control because I'm going out the door, down the hill, up Main Street. I'm circling the globe 3 times all the way to infinity. And I want to get a sum. I want to figure out, I want a total number. I want a number of what you get when you add all those numbers together. Well, if it never ends and it's getting bigger and bigger and bigger, it is out of control. So my question is how am I going to get a sum? Can you do that? No. So half of the problems today that you will be given, you can't do. Okay, and so what do you say? What's the sum of that? You'll say, does not exist. That's what you will say. Half of the problems, though, you will be able to do. No, don't be lazy. Does not exist. Do they always get bigger and bigger and bigger and bigger and bigger and bigger and bigger? What if they get smaller? What would I be timesing by if I was getting smaller? No, because if you times by a negative, you'll get a negative. But then when you times by a negative to a negative, you'll get a positive. And then when you times, so what kind of fraction? Not just any fraction. A fraction that is less than 1. So let's look at an example. If it's going to get smaller, I need you to use your CS brain. Let's times by a half. That would be easy enough, right? Let's times by a half. So if I take half of 16, I get 8. And then I would get, and then I would get, and then I would get, and half of 1 is a half. Half of a half is a quarter, and then an eighth, and then a 16th, and then a 32nd, 1 over 32, then 1 over 64, then 1 over 128, then 1 over 256. And so here's what's happening, and I want to get a sum. Okay, so watch. I want to add this plus this, but I'm going to infinity. What's eventually, do you know what 1/16 is? Do you have an idea of what 1/16 is? Like, let's take one whole sheet of paper. This is one whole sheet of paper. What is 1/16 of this? If I split this into 16 pieces, and I took one of those pieces, that's 1/16. And then I'm going to add 1 over 32 with it. What's 1/32? If I split this one whole into 32 pieces, and then I took one of those. And then I'm going to add to it 1 over 64. If I took this one piece of paper and split it into 64 pieces and took one of those, and I'm going to infinity, so it's going to keep getting littler and littler and littler all the way to infinity, and it's going to get so little. What's going to happen? I heard it's almost like it disappears. It gets so little, because I'm going to infinity. Like, I'm going to keep going littler and littler and littler to infinity. And this is what's hard for us to understand, because we don't know what infinity looks like, right? Does that make sense? We can't, like, oh, that's infinity right there. We can't just reach out and grab it. Like, this is something beyond our thought process here, okay? It's getting so little that pretty much I'm adding 16 to 8 to 4 to 2, and I'm trying to get a sum. Eventually, it'll be so little that even if I add it, like, I want you to think like point, decimal, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, that little. Like, you can't even see it in a microscope. Do you understand how little I'm talking about? Even if I add that number to this amount, will it change it? And then if I get it even smaller and I still add that to it, will it change it? So my question is, someone said, so basically what you're saying, Miss Coins, is that it's going to get so small that I've added all these numbers together, and it's gotten so small that it's like, what's the purpose of even adding it to it, because it's not affecting it? Like, I'm adding these numbers, and they're so microscopic that the sum's not going to change. The number, so you can get that sum, and we call that convergent, when it converges to a number, and it gets to this number, and no matter what we add to it, it's still going to stay this number. So half of the problems today we won't be able to get, because they're getting bigger and bigger and bigger and bigger and bigger, and so they are spiraling out of control into infinity. We call those divergent. Okay, if something diverges away, it, like, you know, goes out of control, and I can't wrap my arms around it to get the sum. But if it's getting smaller and smaller and smaller and smaller and smaller, they will converge. You can get a sum of those. Okay, so a little bit of definitions. First of all, today we're going to look at an infinite geometric series. It's a series that has an infinite number of terms. And we're going to look at two types. We're going to look at convergent series. It's a series that has a sum, because it's getting smaller and smaller and smaller. Again, eventually you'll be able to get a sum. How many people, raise your hand if you understand that idea, that it gets so small that even if you add a number to it, it's so microscopic that it's not going to change? How many get that? Kind of get that? Okay, good. Because that's a hard thing. I will tell you, the technical definition of this is you got to look at your common ratio. If the absolute value of your common ratio is less than 1, then it is convergent. So, hint, 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 for your homework today, like, what if my common ratio is -3? Everybody says negative 3 is less than 1, but it has to be the absolute value of it. What's the absolute value of negative 3? Is 3 less than 1? No. It's got to be something basically between negative 1 and 1. It's got to be a fraction, something less than 1. Okay, it's the absolute value. Divergent, those are the ones that are getting bigger and bigger and bigger and bigger and bigger. Those do not have a sum. Does not exist. You can't do it. It's not possible. Okay? And the absolute value of those, the ratio, is greater than or equal to 1. Okay? If you're timesing by something by 1 or something greater than 1, it's going to either stay the same or it's going to get bigger and bigger and bigger. And you won't be able to get a sum. Any questions about that? All right. Do I have this? So let's look at example 1 and 2. I want to know, is the series convergent or divergent? First of all, why does it have a plus sign? I thought if you were adding to get the next term, it would be arithmetic. Why does it have a plus sign? Because we're getting the sum. Does that make sense? These are still geometric. I still want you to understand that these do have common ratios. You are still multiplying to get the next term. But the reason it has a plus sign between it is because we're specifically talking about a sum. What you get when you add it all together. Okay? All right. So what do you think about example 1? Do you think that one is possible? Is this one, look at 54, and then I go to 36, and then I go to 24. Is it getting bigger or smaller? So this one's getting smaller and smaller and smaller and smaller to infinity. Will it eventually round or converge to a sum? Yes. This one's possible. Okay? This one I would say is convergent. So someone says, Miss Corns, can you just look at these and tell? Yeah, I can just look at these and tell. If it's getting smaller, then it's going to converge and get a sum. But if it's getting bigger to infinity, those are not possible. Okay? Technical, though, R has to be, in order to do this one, R has to be less than 1, the absolute value of R. So let's look at this. What am I multiplying by 54 to get 36? What's the common ratio? If you don't know, what can you do? How do we work backwards? We can divide 36 by 54. What's 36 divided by 54? Try again. 2/3, I believe it should be. My question is 2/3 less than 1? Yeah. So because it's less than 1, that makes it convergent. We will be able to get a sum for that series all the way to infinity. It's going to get so small that it eventually gets to such a small number, a number we can't even fathom, that even when you add it, that number, it won't change. It will not change. Okay? Let's look at example 2. Did you have a question really quickly, Kirby?
Oh yeah. If you like take them away, why can't you go negative? Half zero. Keep going. Can
You talking about to get a sum? If it's less than,
no, either way, can't get a sum. Both can't get both ways.
right. So even if it's getting bigger in the negatives, do you understand what I'm saying? Even if it's getting bigger in the negatives, it's still going to be out of control. Okay? So it has nothing to do with the R being a positive or the R being a negative. It's, it has to do with, are you timesing it by something less than 1, and that's making it smaller? or are you timesing it by something greater than 1, which makes it bigger? So I agree. You can go to infinity in the negative direction as well. And if it's getting bigger and bigger and bigger in the negative direction, it's still not going to be possible. Does that help answer your question? That's why it's the absolute value of R. Okay, example 2. Look at it first. Am I getting bigger? So my question is this one going to be doable? No. We're going to say this is divergent. Like, look at your problem. But if you want to get technical about it, let's look at the common ratio. What am I timesing by 8 to get to 12? And if I don't know, work backwards. The opposite of multiplication is, so divide 12 by 8. 3/2. And everybody says, that's a fraction, Miss Corns. You said a fraction makes it smaller. This is bigger than 1. Not all fraction. If it's a fraction, it's got to be a fraction less than 1, which means the numerator needs to be smaller than the denominator. This actually is 1.5. Is 1.5 bigger than 1? So because R is bigger than 1, it'll be divergent. So this one, the sum does not exist. It's just not possible. Okay? It's getting bigger and bigger and bigger until it's just out of control. Okay? All right, so let's actually put it to some use. Here's your formula today. It is on your formula sheet. It says the sum of an infinite series. How do you know it's infinite? Yeah, it's got the sideways figure 8 right there. That's the infinity symbol. Okay, is equal to a sub 1 divided by 1 minus r. And it does give you a little stipulation up there. What does it mean when it says the absolute value of r has to be less than 1? You're right. It's got to be less than 1 in order for us to do it. Remember, we just said if it was the absolute value of r was greater than 1, it's not going to be possible. Okay? Everybody good? All right, so let's look at example 3 and 4. Okay? So first, you need to decide, is this one we can do, or is this one we can't do? Okay? Is it convergent, or is it divergent? So let's look at the common ratio. What am I timesing by 2/3 to get to 6/15? And again, if you don't know that, you can divide 6/15 by 2/3. Just make sure you put parentheses around your fractions. I hear that I'm timesing by 3/5. So my question is this one okay to do? Is this convergent or divergent? It's convergent. I can get this one. It's getting smaller and smaller and smaller and smaller and smaller. It will eventually converge to a sum that I could actually get. So let's look at our formula. A sub 1 over 1 minus r. So my sum is going to be equal to, do I know a sub 1? What's a sub 1? 2/3. It's your first term. Divided by 1 minus, what's my common ratio? 3/5. And you got to put parentheses around those. So just make sure, if you're going to put this whole thing in the denominator or in your calculator one time, make sure you put an extra set of parentheses. So do this with me. Make sure you can get it. Parentheses. 2 divided by 3. Close parentheses. Divided by parentheses 1 minus parentheses 3 divided by 5, and then double close the parentheses. Math enter. What do we get? 5/3, which is about 1.6 repeating. So again, if we started with, this was 0.6 repeating, and we added 6/15 to it, and we added this, and we went all the way to infinity, you would eventually, it would converge to be 1.6 repeating when you added it all together. Does that make sense? Okay, how about example 4? You got to decide, is this one you can do? Is it divergent or convergent? How do you know it's divergent? Yeah, it's getting bigger. So we know right off the bat this one's going to be divergent. Okay, if you want to get specific about it, what's the common ratio? What am I timesing by 16 to get to 20? And if you don't know it, work backwards. What's 20 divided by 16? Which is greater than 1, right? That is bigger than 1. So what do we say about our sum? What do we write? We write does not exist. You cannot do it. Any questions about that? Okay. So you do these two on your own. I want you to find the sum if it exists. If it's not possible, then write does not exist. What do we think about example 5? Divergent. So what do we think about its sum? Does not exist. Does everybody understand that? Does not exist. Okay. And you can look at it. What was the common ratio here? I know the common ratio? 3/2. And that's really like 1.5. So that's bigger than 1. So that's why it's getting bigger and bigger and bigger and bigger and bigger. It is divergent. So it does not exist. Any questions on that? How many had does not exist? Good. All right. How about example 6? Is that one getting bigger, or is it getting smaller? It's getting smaller, so it is going to be convergent. What's the common ratio? -1/2. Now, is it convergent because it's a negative and it's less than 1 because it's a negative, or is it because it's a half? It's because it's a half. Remember, it's got to be the absolute value of the common ratio. The absolute value of -1/2 is a half. And because a half is less than 1, that's why it's convergent. Okay? All right. So we can plug into our formula, and we can get the sum here. A sub 1 over 1 minus r. So we would get 4 divided by 1. Be very careful here. What would I write? 1 minus -1/2, and I'm glad that you said parentheses. So that actually is a double negative. Remember, if you're going to put it in your calculator all at once, you got to put an extra set of parentheses around it. It is plus a half. Sure. Okay. Well, when you're looking at, like, what if my r comes out to be -3? Would that be convergent or divergent? Right. The absolute value has to be, in order for it to be convergent, what's the absolute? Has to be less than 1. Some people say -3 is less than 1 because it's a negative. But you got to look at the absolute value when you're looking at your common ratio. Yeah, it does. Well, the absolute value of -1/2 is that less than 1? So therefore it's convergent. No, you plug in what it actually is. The formula says nothing about the absolute value. The absolute value just comes into play when you're deciding convergent or divergent, because it's got to be less than 1, the absolute value of it. Okay? All right, so what do we get when we plug all this in? What's our sum? 8/3. So there's your sum. Kirby, question.
So all that together, 8/3.
Yes. And, well, good. I'm glad you said that. But let's try it. Ready? Do it. 4. Put it in. Do this for me. 4 plus -2. What do you get when you add that together? 2. 2 plus 1 is 3 minus a half is 2.5. Okay, and you said the next one would be positive 0.25, right? So add 2, positive 0.25. 2.75, and then add, the next one you said would be negative 0.125. So you get what? Does that make sense? And then keep going. The next one would be 0.0625 or plus 0.0625, I think. 625, 0.0625. And so do you see it's hanging right there, right around what? 8/3. And if you keep going, it's just going to go like this. It's going to go a little bit above it, a little bit below it, a little bit above it, and then eventually it's just going to get to the point where it's not going to even move. Okay? Yay! Good. All right, for candy, really quickly, before lunch. I want you to see if you can figure that one out. And first person to tell me an issue with this gets a piece of candy. Kennedy. How do you know the half is the R? Ah, yay! I could just give you both pieces of candy because you did it all in one step. Okay, so this one will work. What's the issue in your calculator? I'll still give you a piece of candy with this. How many went right to Math 10 and went to your summation key? You were like, heck yes, I can do this. How many thought that immediately? What's the issue? There's no infinity sign. And I searched Google for a while, and there's still, I can't find the infinity sign in the TI calculator, okay? So Kennedy said she thinks that this looks like old reliable. Remember, we had a formula yesterday that looked like this. A sub n equals a sub 1 times r raised to the n minus 1. Does that look like? Yes. And in this case, we can get the sum because my common ratio is a half. Is a half less than 1? So you can use your formula, can you not? And we could do a sub 1 over 1 minus r. You can use 10 for a sub 1. And you can use 1/2 for r. Did you get that? So you're not going to be able to put these in your calculator. Dag, blast it. Okay? But you can plug into your formula. So do that really quickly for me. Because it follows your formula. It follows your geometric formula. So what would I divide? I would divide 10 by 1 minus 1/2. So tell me really quickly, what's the sum? 20. Okay? Very last one, and we will be done. Okay? I'll leave you for that one for lunch, and we'll finish that one up. This is the last example, though. All right, so let's pick up here after lunch. So, just a reminder, if you saw this on an SOL, and again, I have seen this on practice items and sample questions, you know, we see that, we try to go to the calculator. But the issue is, it's got an infinity sign up there, okay? What if you chose a number, like I had somebody in second block today that went from 1 to, and they couldn't go to infinity, but they chose like the highest number they could. Like I think it lets you put something up into the thousands. So they chose 9,999. Does that make sense? And then they put this in. It worked for them. Does that make sense when they put it in the calculator? But if you want to get technical about it, because again, it's eventually going to get to a point and it's just going to converge to a certain number. So this mimics the formula a sub 1 times r to the n minus 1, which that would make 6 a sub 1. That would make negative 1/3 your common ratio. So if we plugged into our formula, we would get 6 divided by 1 minus negative 1/3. And I agree that does mean 1 plus 1/3. And so what does our sum come out to be? 9/2. Okay. Anybody try it the way I just said by picking, like, you can't put the infinity sign, but try it by putting in like 9,999, like something pretty large, to see what it converges to. I'd be curious if it came out to be 4.5 or math enter 9/2.